Hello guys, welcome to all of you. Let us see a question on region of operation of BJT. In this question, it is said that the circuit shown below, beta value is given 30 and it is a silicon transistor. Find the region of operation and output voltage if these three conditions of VI voltage and R1 resistance is given. So this is the circuit given to us. Let us see how can we solve it. In the given circuit, VI voltage is given as 12 volt in first condition and R1 resistance is given as 15 kilo ohm. To find out operation, first of all, we will assume that this transistor is working in saturation region as we have seen in our last examples. If we calculate collector current value in this circuit, then we can find it by applying KVL in this output loop. If we apply KVL, then we can write as 12 minus 2.2 IC minus VC equal to 0. Since this transistor is working in saturation region and it is a silicon transistor, then VC voltage will be equal to 0.2 volt. So we have put VC equal to 0.2 and VI value 12 volt, RC value 2.2 kilo ohm. Then ISAT value can be calculated as 5.36 milliampere. Now we can apply KCL at this node, then it will be equal to I1 equal to IB plus I2. This I1 value will be equal to IB plus I2. IB can be written as I1 minus I2 from this equation, and here we can see I1 equal to VI minus VB upon R1. This I1 can be written as here VB voltage will be added at this node, then VI minus VB upon R1 can be written as I1. So here we have put the value of I1 and minus I2 value can be written as this voltage is VB at this node and this is minus 12 volt, then VB plus 12 upon R2. Now we put the value of VB is equal to 0.8 volt since this is a silicon transistor and it is working in saturation region. So VB equal to 0.8 volt. Upon R1 value is 15 minus VB voltage 0.8 plus 12 upon R2 value is given in the question 100. IB value will be equal to 0.618 milliampere. We can calculate minimum base current required this transistor to operate in saturation region. It will be equal to IB minimum equal to IC sat upon beta. We have calculated IC sat is equal to 5.36 milliampere. We put it here. Beta value is given in the question, that is 30, and its value will be equal to 0.178 milliampere. Since IB value is greater than IB minimum, IB value is 0.618 and IB minimum is 0.178 milliampere. So we can say that this BJT will work in saturation region. So from the circuit, this V0 will be equal to VC and it will be equal to 0.2 volt. So in the first condition, when VI is equal to 12 volt and R1 is equal to 15 kilo ohm, then its output value will be equal to VC and that value will be equal to 0.2 volt since this transistor is working in saturation region. Let us see next condition. In the next condition, it is given that VI is equal to 10 volt and R1 is equal to 40K. Then we have to find out the region of operation of this transistor and the output voltage. In the similar way, as we have assumed in our first problem, we will assume here also that this transistor is working in saturation region. So ISAT current will flow from this transistor. Since ISAT current is flowing, then we will calculate IB minimum as we have calculated in first problem. IB minimum value will be same for this second problem also. So its value will be equal to 0.178 milliampere. Here I1 can be written as IB plus I2 and IB value will be equal to I1 minus I2. We can calculate I1 by this equation and I2 by this equation. Now here we can see that VI voltage is 10 volt, VB voltage is 0.8 volt when this transistor is in saturation region, and R2 value is given as 100 kilo ohm here. So we can calculate IB value is equal to 0.102 milliampere. So we can see that this IB value is less than this IB minimum value. So BJT will be in active region. We have assumed initially that BJT is in saturation region, but now our calculation says that BJT should be in active region. So now we will assume that this BJT is in active region and we will solve the problem accordingly. Now here IB value can be written as I1 minus I2. We have put the values as these equations. We can calculate it from the circuit. Now we have assumed that BJT is in active region. Base to emitter voltage will be equal to 0.7 volt for silicon transistor if it is a NPN transistor. So VB voltage will be put here 0.7 volt and all the values will be same as here. So IB value will be equal to 0.10555 milliampere. So we need to cautious for this that if transistor is working in saturation region and transistor is a silicon NPN transistor, then VB voltage will be 0.8 volt. If this transistor is working in active region, then its VB voltage will be equal to 0.7 volt. Now IC can be calculated as beta into IB. This formula is applicable only when the transistor is working in active region. So IC value will be equal to beta is given in the question 30 into IB value we have calculated here. Then IC will be equal to 3.165 milliampere. If we apply KVL here, then we can find out VC equal to 12 minus 2.2 IC and this VC will be equal to V naught. So we have written here V naught equal to VC equal to 12 minus 2.2 IC. We have calculated the value of IC here, put it here, find out V naught equal to 5.037 volt. So V naught will be equal to 5.037 volt when Vi is equal to 10 volt and R1 is equal to 40K, and this transistor will work in active region. Now let us see next problem. In next problem, it was said that Vi voltage is 1 volt and R1 is equal to 15 kilo ohm. Then we have to find out the region of operation of this BJT. IB minimum is equal to 0.178 milliampere as we have calculated previously in problem 1. The value of IB minimum will not change since its value will depend on IC sat only, and we will assume in every circuit that this transistor is working in saturation region initially. Now IB equal to I1 minus I2. We have calculated the value of I1 and I2 as previously. Here we can put Vi equal to 1 volt and VB is equal to 0.8 volt since we have assumed that this transistor is working initially in saturation region. So we can find out IB equal to minus 0.115 milliampere. As we can see here that IB value is negative, so this transistor will work in cutoff region. Since this is working in cutoff region, so we can say that this BJT will be off. Since it is off, so all current will be 0. We can say that IB equal to IC equal to I equal to 0. If a transistor is working in cutoff region, then all the current values will be 0. So output voltage can be written from the KVL here, VC equal to 12 minus 2.2 IC. Since IC value is 0 here, so V naught can be written as 12 volt. In this way, we will first assume that our transistor is in saturation region, and according the calculation of IB minimum and IB, we will compare these values and we will interpret that in which region our transistor is working. According to that, we will next solve the problem and we will calculate the parameter which is asked in the question. If IB value is greater than or equal to IB minimum, then we can say that BJT is working in saturation region. If IB value is less than IB minimum, then this BJT will work in active region. If IB is negative value, as we can see in this third problem, then BJT will be off. Then all the current values will be 0, and accordingly we can find out the parameter asked in the question. See you guys in next video.